When solving for Hardy-Weinberg, there's two formulae that we need to know. P plus Q equals 1. And for genotypes, P squared plus 2PQ plus Q squared equals 1. P is the frequency of the dominant allele in a population, or a capital A. Q represents the frequency of the recessive allele in a population, or lowercase a. The genotypes for P squared is the homozygous dominant genotype. For 2PQ is the heterozygous genotype. And Q squared represents the recessive genotype. Using these two formulae, we can determine whether evolution has occurred. So if the frequency of one of the alleles or one of the genotypes has changed, then we say evolution has occurred. Steps to solving Hardy-Weinberg questions. First, write down your known unknowns, and then follow these steps. If you can, try to start with Q squared because there's only one genotype for it, and that's little a, little a. Once you have Q squared, you can find Q by taking the square root of Q squared. P, we rearrange the equation from P plus Q equals 1 to P equals 1 minus Q. P squared, we square P, or we can multiply P by itself. And last, to find 2PQ, we multiply 2 times P times Q. So just a reminder of the genotypes. Q squared is homozygous recessive. Q is the recessive allele. P is the dominant allele. P squared, homozygous dominant genotype. And 2PQ is the heterozygous genotype. Let's try an example. 7 out of 9 mice are brown. Brown is dominant to white. Let's solve for all of the factors here. So let's start by saying that 7 out of 9 are brown. That's the dominant trait. We want to see if we can start with recessive. So we're going to start with 2 out of 9 must have the recessive trait if 7 out of 9 are dominant. So that's our Q squared, 2 out of 9. When we divide 2 by 9, we get 0.2 repeating. To find the square root of Q squared, we square root that number, and then we find the frequency of the lowercase a allele. Then we'll subtract that number from 1 to get P. Then we can square it to get P squared. And finally, to get 2PQ, we're going to multiply 2 times our value for P times our value for Q to get the frequency of that. Now, if we were asked one more thing, what is the, or how many in the population were heterozygous, then we would do one more step. We would multiply the frequency of the heterozygous individuals by the number of individuals in the population. So we times it by 9 mice to get 4.48 mice are heterozygotes, or in other words, 4 would be our final answer because we can't have 0.48 of a mouse. Let's try another example. In a population of flying pigs, some pigs have stubby wings. If there were 50 pigs in total and 8 have the recessive trait of stubby wings, how many are homozygous for the dominant allele? Let's start here. We have 8 are recessive, so that means 8 out of 50 is Q squared. We're looking for homozygous for the dominant allele, which was P squared. So let's start here at Q squared. That's 8 over 50, which is 0.16. Remember, our next step is to go to Q. Q is the square root of Q squared, which is 0.4. Next step, we can find P. P is 1 minus Q, which is 0.6. And finally, we're at P squared. We're going to square 0.6 to get 0.36. And we'll read the question to see, are we done? If there were 50 pigs in total and 8 have the recessive trait of stubby wings, how many are homozygous for the dominant allele? So we have found a frequency Now we're going to multiply that frequency by the total number of pigs in the population to get our final answer. 18 pigs have the are homozygous for the dominant allele.